Hello everyone, this is the final project on using AI to predict the energy output of a combined cycle power plant. Well, in this project, we build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. So we have a set of 9,568 hourly average ambient environmental readings from sensors at the power plant, which we will use in our model. Since we are predicting a numeric target variable, I have applied a linear regression based supervised learning model. I have evaluated two linear regression models which were based on two independent sets of features. That is, they both use the same algorithm but rely on two different sets of features. I have chose to use Google's AutoML for the modeling. Well, on the screenshot, you see how it looks like on GCP after the data has been imported. Now let's dive into the models and the features. The dataset provides four features that we have to use to predict the target variable. In model 1, I used all four features to predict the value of target variable. Based on the output of model 1, I have realized that ambient temperature and the exhaust vacuum were far more important for the prediction compared to the relative humidity and the ambient pressure. Therefore, in Model 2, I only used ambient temperature and exhaust vacuum as my features. That's the distinction between the two models. Well, on the slide, it shows a visual comparison of the relative importance of these features in Model 1 versus Model 2. Splitting data and cross-validation. Google's AutoML automatically does a default 80% split for training, 10% for evaluation, and 10% for testing. The tool does provide a manual option to split the data. However, it requires the user to manually update the Excel format or CSV data into a format that Google can read and split the data appropriately. I did not have the time to figure out how to use a manual option, so I'm stuck with the default 80-10-10 data split that AutoML does and continue for the project. Since we are evaluating a linear regression based model, I initially looked at the outliers or the extent of the outliers in the dataset using conditional formatting on Excel. Since there weren't many outliers or large outliers values, I have chosen to use mean absolute error as one of my evaluation metrics because I'm really trying to measure if my predictions are off by a little each time versus the large outliers. I have also chosen R squared to understand the extent of variance in our target values that the model can appropriately and suitably explain. So based on this, I ran the two models on the 10% of test data. In conclusion, I believe Model 2 would be my preferred solution for the following reasons. Firstly, it has a much better R-squared value and the model is able to explain 96% or greater of variance in our target variable compared to roughly 88 in Model 1. Model 2 has a slightly higher value of mean absolute error by 0.104 megawatt compared to Model 1. But the slight increase in MAE, I believe, is an acceptable trade-off given the overall accuracy of the model. Lastly, Model 2 also have much lower RMSE value compared to Model 1, which indicates there are much fewer outliers in Model 2 versus Model 1. Hence, I believe Model 2 does a better job of predicting the energy output of this combined cycle power plant, even though it only uses two features versus four features in Model 1. Well, on this slide is the final screenshot of what it does look like on Google Cloud after the models are completed. Thank you.